say, oh yeah, oh yeah, yeah, yeah. I can't complain, but something absolutely life's been good to me so far.
All right, hi there. Today I'm going to be looking at absolute value. Functions and graphs. So this is the big equation we're going to be working with today. Y equals a times the absolute value of x minus h plus k. Like most equations, it's got an x and a y. The three things that we're really looking at are these three variables, a, h, and k. All right, and I'm going to describe this, and then I'm going to use an online graphing calculator to illustrate how these variables affect the graphs. So the first thing is if I take the numbers right out, h and k, that'll be the vertex, okay? The axis of symmetry will be x equals whatever h is. I'll give you a more concrete example in a minute too. Also, if a is greater than 1, it's what's called a stretch, so the graph gets stretched out. If a is less than 1, then it's a compression. If a is negative, it's a reflection. And h is the horizontal translation, and k is the vertical translation. Translation means how the graph moves, okay? And I know this, if you write this down first, we'll come back to it and I'll illustrate it and make it make much better sense, okay? So that's really the meat of this lesson is just that, working with that equation. And there's going to be a whole bunch more of these coming up, these types of translations, stretches, compressions, reflections, etc., etc. So it keeps coming up over and over again. Trust me, you'll get it really well by the end of this class. So I am going to go over to one of my favorite apps called Desmos, which is a free, I said free online graphing calculator that you can use. So I'm going to start with the most basic of absolute value equations, y equals the absolute value of x. Okay, which is a v. All absolute value graphs are a v, all right? Now, that v can move around and shift some. So let me start off with, I'm going to leave that one there, and everything is kind of built off of that. That's called the parent function, y equals the absolute value of x, okay, for this type of function. Now, if I was to go y equals the absolute value of x minus 2, the minus 2 inside the absolute value, you can see that it moved right 2 units, okay? That's the horizontal. It went actually the opposite direction of what I thought it would. When you see that minus 2, I would have expected it to go left 2, but when it's inside the absolute value sign there, that's what happens. It moves the opposite direction than you'd think, okay? So suppose I made it plus 3 instead. Plus 3 inside of there, you can see then it moves left 3. Okay, so when it's plus, it moves left, and when it's minus inside the absolute value, it moves right. And you should jot a couple of these down on your graph papers too, and write them down so you've got some of the graphs with the equations. Okay, next one. I'm going to do one where I've got the number outside the absolute value. So if I have this, the absolute value of x, and then I go plus 3 on the outside now that's what we call vertical translation. It moved the graph up. Believe it or not, these two graphs right here, they are the same, okay? The only thing that's different is where they cross the y-axis, okay? So suppose I was to make it a minus 2 instead of plus 3, what do you think would happen to the graph then? I guess we'll see. There you go, it moved it down 2, okay? The vertical translation, when it's minus, it goes the way you'd think it would. It moves the y-intercept down 2, Okay. Now maybe I'll pull a couple of these things together. Y equals the absolute value of x plus 3 inside the absolute value sign, and then minus 2 outside. Well, you can see it moved that v left 3 and down 2. Now, if I was looking for the vertex, if I asked you what the vertex of that absolute value equation is, the vertex is like the bottom of the v, all right? Which in this case would be negative 3, 2. And you can see that it's right there on that graph with negative, that's the point of the v, okay? And if I had asked you what's the axis of symmetry, the axis of symmetry is a vertical line that goes through the vertex. So in this case, it would be x equals negative 3. And you can see that's that vertical line, the vertical green line on there, going right through the middle of the vertex. So, and I got that 3 right from, next to the x in that equation. Y equals the absolute value of x plus 3. It's the opposite sign, so it's negative 3, all right? Okay, so let's see. Moving right along, let me delete that and go back over here. Suppose I kept that same equation, but this time I put a number in front of the absolute value sign. I'll do it up here so we can see. So if I take this one and I keep it the same, plus 3, but then I put the minus 2 outside it, and now in front I'm going to put a 2. This is what's called a stretch, because it's like somebody pulled the graph up, all right? It stretched it out vertically, really. You'll also notice that the slope of that v there is now 2, positive 2 and negative 2 of that red line. That's the slope, all right, of that line. So if you're graphing it, you start with, where the vertex is, which is negative 3, 2, and then you do a slope of 2. And it goes straight up, right up to the right 2, and slope of negative 2 going up and to the left, okay? So that A is going to be the slope of the V, and that's important when you're graphing it by hand. All right, so that was our stretch. Let me show you a compression now. Suppose I didn't do a 2 there, but I made it a 1/2 instead, or a 0.5. Well, you can see it's a compression there. It's like you pushed down on the graph, and it pushed it out, made it shorter and fatter, for lack of a better way to describe that. Anyway, so that's a compression. It pushed it down. And let me take a moment now, so hopefully you got an idea. Jot a couple of those graphs down. Now I'd like to see what happens when I make one of these negative. I think I'm going to get rid of this. So suppose I had that same, we'll take the same equation, y equals the absolute value of x plus 3. And then outside the absolute value, I have minus 2. Now, if I was to put just a negative 1 or just a negative sign in there, you can see the graph is actually the same, but it just flipped it upside down. It's called a reflection, and you reflected it right across that line there, right across the vertex. So it's the same graph, except it's a reflection, and hopefully you remember your reflections a little bit from geometry. Hopefully they taught them to you there, but we'll get more reflections here also. So if I was to get rid of the plus 2, or the minus 2 on both of them, you can see there's still a reflection. It's just the vertex moved over to negative 3, 0, okay? Yeah, okay. So let's see. All right, so going back to my graph, I'm going to leave this one here. And go back up here. Suppose for a minute I gave you a graph and I asked you to go the other direction. This can be sometimes interesting. And I had this graph over here. Oops. And I put it like that, and I asked you, what's the equation of that absolute value? Could you tell me? And I know it may not be quite perfect, but we should be able to do this pretty well. What you really want to do first is find the vertex. Just write it down. What is the vertex? In this case, it's, this point right here in the middle where the V makes. All right, so that would be 2, -1. And what is the slope of this line? The slope of this line is 1. So A is actually going to be 1. All right, it's not going upside down. It's a regular facing up V, so it's +1, not -1. So if I was to go and write the equation, and the vertex is 2, 1. When I plug this in, I get y equals, you could put the 1 there, it's already implied. X minus h is the x coordinate, which is 2, plus -1. All right, now, like I said, you can erase the 1 if you want. That's the equation, though. Okay, see how the 2 becomes negative once you plug it into that equation? All right. Okay, so that was problem number 1. Here's problem number 2, where I'm going to ask for what is the equation of this graph? Okay, so let me start with this. The vertex, let's start there. The vertex is that point right there. Okay, now the x value, this is -1, -2, -3, is -3, and the y value is -2. Okay, so let's start with that. I can plug this into that formula, y equals a times the absolute value of x minus h plus k. Okay, and when I plug those values in, I'll leave a blank for the moment. X minus -3 plus -2 or -2, that's the same thing. Now, you'll see what happens when I have a double negative there. You got to clean that up, make it a plus, okay? And I'll put that in the final version in a moment. Now, the other thing that we need to figure out is A. A is not upside down in this case, because if it was going that direction, an upside down V, then it would be negative. In this case, it's positive. But what's the slope of that line? The slope of those V's are going to tell you what A is, okay? So if I, for a moment, just go rise over run, and hopefully you remember some of this from your math. You can go from anywhere you want. I'm going from here. Another point where it hits the hash mark is here. Make a little V. That's run is 2, rise is 1. Rise over run. Run over rise. Is 1 over 2. So that's actually what A is, okay? If you'd gone over here, you would have gotten -1 over 2, but that's also the left side. So 1's always going to be positive, 1 will be negative. So you always just put the +1. If it was negative, then it would be upside down. It would be the same V, but upside down. Yeah, all right. So this is the equation that I'm looking for this. Let me write down the final version over here. Y equals 1/2 the absolute value of x plus 3 plus -2, all right? Or -2. All right, number 3, what's the graph of the equation of this graph? All right, once again, I'm going to start with the vertex. The vertex of this one, let's see, here's x is 1, y is -2. So when I start plugging this in, I'm going to leave a blank for a moment. X minus 1, X is the x value goes next to the x, and the y value goes at the end. I'm just going to put minus 2 this time. Okay, now a, once again, it's going to be positive, and I need to figure out what the slope of this line is, which would be rise over run is 2 over 1, which is going to be my slope, and that will be a. All right, so that would be the equation of that graph. So hopefully that sheds a little light on how we graph an absolute value equation. And if you got questions, please bring them to class. I'm going to close it out with a little bit more music. Have a great night.